Today is lesson one of our new unit where we're going to be talking about expressions and equations and inequalities. First lesson is going to just kind of give us get our feet wet back into looking at expressions again. So we are going to start looking at equivalent expressions. And it says, today I will demonstrate my mathematical ability to utilize the commutative and associative property to create equivalent expressions through cooperative learning. Let's go ahead and get started and see how this plays out today. Okay, these are the words that should be in your toolbox for today. There's a lot of them, but they should be words you already know. Okay, well, let's look at the first word. We have variables. Variables are simply letters. Okay, they're letters that represent numbers. Okay, that represent numbers. Okay, and then we have coefficients, and these are the numbers with the variable. Like 3x. Okay. I have an expression. An expression is simply a numerical phrase. Okay. So with an expression it'd be like 3 plus 4. Okay. Now I could also have A plus B. This would be my numerical expression because I'm using numbers. This would be my variable expression because I'm using variables. Okay. My equivalent expressions would be two expressions that are equal to each other. So I could have, we're going to talk about equivalent expressions. We're going to talk about expressions in expanded form and in standard form. Alright, let's go ahead and get started. Okay, we're going to first start looking at these two expressions. And it says, write the original expressions. And then so I've already written them for you. I want you to expand them using addition. So if I expand these out, 5x expands out to x plus x plus x Okay, so I have 5x's here. I remember with hands-on equation it was 5 pawns. Alright, now I'm going to add to that 3 more x's. Okay, now this would be in expanded form. I expanded this all out. Now, when I combine all these, how many x's do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. So 5x plus 3x gives me a total of 8x. Okay. Let's look at this next one. I have 5x, so I'm going to put my 5x's out there. And I'm adding in between all of these. Okay. I'm going to take 3 of them, and I'm going to take them away. So that means I'm left with 2. So 5x plus a negative 3x, because I want to change it to by adding its opposite. Okay, so this would actually equal 2x. Would be my answer there. Alright, let's go ahead and look at another problem. So this was expanded form. Okay, this is what I call standard form or the simplified form. Okay, expanded, standard. Okay, so on this problem here, we're going to have 2x plus 1 and 5x, and I want to know the sum. So I'm going to first write out 2x plus 1 and 5x. Okay, now I'm going to first use my commutative property because I'm going to change the order. So I'm going to go 2x plus 5x plus 1. Okay. Now 2x plus 5x. If they have the same last name, I have an x here and I have an x here. Okay? They're related. They're brother and sister. So if they're related, I'm going to combine them into one main family. Because say I have 2 brothers and I have 5 sisters. Well, how many siblings do I have? Well, I have 7 siblings in this family. Okay? Plus 1. And this 1 is called my constant term. So if I want to know what the sum of 2x plus 1 and 5x is, it's going to be 7x plus 1. Alright? Now, if I want to see if these two are equivalent expressions, okay, I'm going to change the color a little bit. Okay, I'm going to look at 2x plus 1 plus 5x. Okay, my pen will cooperate with me for a little bit. We'll write it down here. 2x. No, that's not going to work either. Let's try this again. There we go. Okay, so now I'm going to replace my variable. Okay, replace this variable with a number. Let's go easy. Let's pick 1. 1 will be really easy. So I have 2 instead of my variable, I'm going to replace it with a 1 plus 1 plus 5x, or 5 times 1. Okay, well 2 times 1 is 2 plus 1 plus 5. Well, 2 plus 1 is 3 plus 1, or plus 5 is 8. Okay, well we're trying to figure out if these two are actually equivalent. So I'm going to write 7x plus 1. Okay, now I'm going to replace my variable with 1. I need to use the same number here that I used over here. Otherwise, if I change it, it's not going to help me at all. Okay, plus 1. So 7 times 1 is 7. Plus 1 is 8. Okay, so now I know that these both are equivalent expressions because they both equal the same when I input the same number in for my variable. This one's a little bit more of a challenge. I have negative 3a plus 2 and 5a minus 3. Well, the first thing I see is I see subtraction. I'm going to change it to addition. Remember how we do that by adding the opposite. So I'm going to add here. The opposite of 3 is negative 3. So I'm adding the opposite. Now I have everything in addition. Now I'm copacetic and I can go ahead and get started. Well, I'm going to use the commutative property to get my variable terms together. Okay, so I have negative 3a plus 5a plus 2 plus negative 3. Okay, remember this 2 and 3 are my constant terms. They are constant because they never ever change. These are my variable terms because they're going to change based on what this variable is. Now, negative 3 plus a negative 5. Remember, if I have the same last name, I have an A here and I have an A here. They're the same last name. They're the same term. They're related. Now I can just add their coefficients, the number with the variable. So I have negative 3 plus 5. Well, negative 3 plus 5 is 2. So I have 2a plus 2 plus a negative 3. Well, 2 plus a negative 3 is going to be a negative 1. I could either write it like this, or I could write it using subtraction as 2a minus 1. They're the exact same problem. Okay, let's change gears for a little bit, and let's look at multiplication. Now it says to find the product of 2x and 3. So 2x, okay, times 3. Now, if I write out 2x times 3, okay, this means I have 2x times 2x times 2x, doesn't it? Okay. Which means I have 2 times 2 times 2. Correct. So I have 6x. All I'm doing is I'm taking my constant here, multiplying it by my coefficient, and I get 2x. Okay? Because remember, 2x is actually x plus x. Okay? Plus x plus x. Okay? Plus x plus x. I have 1, 2, 3, 4, 5, 6. I have 6 x's. So that's where I get 6x as my answer. So let's do this one. Okay, it's just like what I was talking before. I'm going to take this number, my number outside my parentheses, I'm going to multiply it by the number inside. The distributive property, right? Well, 3 times 2 is 6. So I have 6x plus, well, now I'm going to take this whole term outside times the term inside. Well, 4 times 5 is 20. So it's going to just simply be 20y. Okay? And that's all we're talking about at the moment. Okay? We're not talking about anything else. This is it. Now, it is important, though, that we understand what we're doing and that we understand that all we're doing is simplifying our expressions. This is my simplified. This is in standard form. I could expand this all the way out if I wanted to and have 6x's plus 20y's. This is just, that would be expanded form. This would be the simplified form. Remember, when I have a number with my variable, this is called my coefficient. If I have something like this where I have 6x plus 5, this 5 is my constant term. Okay? It's constant because it doesn't ever change unless I operate to it. I'm going to operate by adding here in this example. It is not related to this one over here, so don't get them confused. Alright? This is a variable expression. If I had something like 3 plus 6, that is a numerical expression. Okay? This is a variable. It replaces a number, or it represents a number. So make sure that you have definitions for every one of your toolbox words. Alright, and if you don't have one, if I didn't talk about one, make sure you write it down for your WSQ, and when we have our discussion at the beginning of class, I'll go over it. Alright, see you in class.